Bismillah ar-Rahman ar-Rahim. Electromagnetic field theory, and today we have to do the numericals for the coordinate system, which we have already studied in the class. So the first example is uh, we have given the m vector m is equal to minus 10ax plus 4ay minus 8az, and n is this one. So we have to find the unit vector in the direction of minus m plus 2n. So first we have to find the minus m plus 2n. We have to multiply minus with this m, and okay. So uh, okay. So we have to multiply minus with this m and 2 with this. So this is minus m, and this is 2n, and after that we have to add minus m plus 2n because of this. Okay, so we will get 26 ax and 10 ay and 4 az. So we are required the unit vector. So what is the formula for the unit vector? A vector is equal to a magnitude into a unit vector. So what will be the unit vector then? A vector divided by a absolute. Okay. Okay, so we will get a unit vector. So this is a unit vector because we are required the unit vector. So this is the vector, and the magnitude of a vector will be 26 10 4. It means 26 whole square plus 10 whole square plus 4 whole square root plus 4 square and whole square root. Then we will divide this single figure by 26 and also by 10 and also by 4. So after dividing this with 26 we will get 0.92, and by dividing by 10 so we will get 0.36, and dividing this number by 4 so we will get 0.14. Similarly, the second part is the magnitude of 5ax plus n minus 3m. So first we have to multiply 5 with ax. So there is no y and z component, so the y and z component will be 0. So we will multiply 5 with the the x component only. So 5 comma 0 comma 0 plus n, this is the n which is given here, and minus 3m. So we will multiply 3 with this m vector, 3 with this. So minus 30, 12 and minus 24. So after adding we will get 43 comma minus 5 comma 22. We can also write this in the form of like this: 43ax plus minus 5ay. This is also the second method for writing, and plus 22az, 22az, and we can write this in the form of parenthesis as well. Okay, so this is 5ax plus n minus 3m. Okay, so we have to find the magnitude. So 43 by the similar method. 43 whole square plus 5 whole square plus 22 whole square root. So we will get 48.6. Uh, this is another example. This is okay. Given points A 8 minus 5 4 and B is minus 2 3 2. So we have to find the distance from A to B. Let's suppose this is A and this is B. So distance from A to B, it means this is the final point and this is the initial point. So to find the distance from A to B, so we will subtract final point minus the initial point. Final point minus initial point. So B minus A, and the distance means the magnitude of the vector from A to B. So B minus A minus 2 minus 8 minus 10, 3 minus double minus 5, so plus 8, 2 minus 4 minus 2, and magnitude by this method we will get this. Okay. Okay, now the unit, this B part is a unit vector directed from A to B. So this is very similar to this, and by this formula, you will find a unit vector pointing from A to B. A towards B means B minus A. So B minus A vector divided by B minus A vector magnitude. So B minus A, we have already find this. This is the B minus A, and magnitude is this one. So we have to divide 12.96 by 10. So we'll get this 12.8 divided by 12.96. We will get this, and minus 2 divided by 12.96. We will get this. Okay. So you have to use the calculator to solve these questions. Okay. Now another example. Two vectors f and g. F is minus 10x plus 20x bracket y minus 1 ay, and g is this one. So for the point P, find f magnitude. P point uh, 2 magnitude 2 units on x direction, 3 in the y, and minus 4 in the z direction. So we have to find the 5 f absolute f, the magnitude for the f vector. So first of all, we have to put these values in f, because we have to find f absolute for this point, for this particular point. So that is why we have to put 2 3 and minus 4 in this, against x, against y, and against z. So there is no x over here, so minus 10. Okay, so we have to solve this bracket. 20xy minus 20, we will get this. So after putting the uh, x is equal to 2 and y is equal to 3, so we will get 80, and there is no z component, so z component will be 0. So there is no z, so we cannot put minus 4 against the z. So by finding the magnitude minus 10, similar method, minus 10 whole square plus 80 whole square plus 0 whole square and square root. So we will get 80.6. And similar is the method for g. We have to put uh, 2, 3 and minus 4 against the g, and after that we will get 24 minus 4 and 4, and using this method we will get 24.7. Okay, now the z component is present here, so we have to put minus 4 against this, therefore the z value is minus 4. Okay, now the c part is a unit vector in the direction of f minus g. Okay, so f minus g, first we have to find the vector f minus g. This is f from here, and this is g vector. So we have to find the f minus g vector first of all. This is f minus g vector. Now f minus g vector divided by the f minus g vector absolute. So this is the f minus g, and how we have to find the absolute, the same method over here, means minus 34 whole square plus 84 whole square plus 4 whole square roots, we will get 90.7. So after dividing 90% by this, 84 minus 84 divided by 90.7 plus sorry comma and 4 divided by 90.7, so we will get this. Let's suppose this is the unit vector for f minus g vector. Now a unit vector in the direction of f plus g. So we have to find first of all the f plus g vector. This is f from here and g from here, so we have to add up, and this is the f minus g vector. Now unit vector, so f minus sorry f plus g vector, f plus g vector divided by the absolute of f plus g vector. So f plus g vector, and by this method we will get the absolute, and dividing 77.4 on each of x, y and z values, you will get this. Very easy, very similar example to the previous slide. It is just the repeated practice for you people. Now move on to the next slide. We have the m and n vector, m, n and p vectors. So the vector mn, the vector mn, we have to find the vector mn. So this is the mn, means from m to n, from m to n. So what does it mean? It means this is the final point and this is the initial point. R means the vector or the position vector mn. So this m will represent the initial value, and this n will represent the final value. So for rmn, so we have to subtract n, this m minus m. So here is the rmn vector. Okay, now the dot product of rmn and rmp. So first of all we have to find the rmp, because we have already find the rmn, but we have no value for the rmp. So similarly, m is the initial vector and p will be the final. So p minus m, we will get rmp. and now dot with the Rmn vector. So Rmp dot the Rmn here from this Rmn. So x, we have already discussed the dot vector in the class. So zero point 0.3 into zero point 0.3 plus, minus zero point 0.3 into zero point 0.3, we will get this, comma zero point 0.3 into zero point 0.2, we will get the y, plus zero point 0.4 into zero point 0.2, we will get this. So this is the dot product of these two vectors. The scalar projection of Rmn on MP. Scalar projection, this is the formula for the scalar projection. Scalar projection means if there is one vector and there's second vector. So this, if this is A and this is B, so this vector can be projected over this, means a shadow of this vector can be found over here. So according to this formula, scalar projection of B on A will be the dot product of these two vectors divided by the absolute of that vector upon which the projection has been fall. So they have been fallen. So the project here the projection is fallen on A. So A dot B divided by the absolute of this A. But in the case of the scalar projection of Rmn on Rmp, so the projection is fallen on the Rmp. So first of all, we have to find the dot product of these two vectors. These vectors are have already been found in part A and B. Here is Rmn and this is Rmp. So first we have to find the dot product Rm, and this is Rmn and this is Rmp, and divided by the absolute of Rmp, because the projection is fallen on Rmp according to this formula. Okay, now dot product is easy. Minus zero point 0.3 into zero point 0.3 plus zero point 0.3 into zero point 0.2 plus zero point 0.4 into zero point 0.2. So we will get this, and from the absolute we will get 0.17 whole square root. So after dividing we will get 0.12. The angle between Rm and Rmp. So according to dot formula, A dot B is equal to A absolute into B absolute cos theta. So if you want to find this theta, so divide A absolute and B absolute over there. The cos theta will be A dot B divided by the A absolute into the B absolute into the B absolute. And now the theta, for the theta, so taking the inverse on both, the cos inverse on both sides, so we will get theta is equal to tangent inverse of this, cos inverse of this. Okay, applying cos inverse on both side, cos inverse on this side and cos inverse on this side, cos inverse on this side. So cos inverse and cos will cancel out. So theta will be equal to cos inverse this. So similar is the case with these two vectors. Theta is equal to cos inverse of the dot product of these two vectors and divided by the absolute of these two vectors. So the dot product have already been found here, 0.5 divided by the absolute of this. Absolute is very easy. point 0.3 whole square plus point 0.3 whole square plus point 0.4 whole square root, and the absolute of this point 0.3 whole square plus point 0.2 whole square plus point 0.2 whole square root. So we, after multiplying these two and dividing by 0.05 and taking the tangent inverse by the calculator, so we will get 78. Okay, move on to the next slide. Okay, this is another example. A point, A vector, A point, B and C and D. Determine the vector projection. Now in here uh, we have to find the vector projections, and I've already uh, provided the formula for the vector projection. The vector projection of B on A is equal to the dot product of these two vectors divided by the absolute of the vector upon which the projection is to be fallen. So A absolute multiply by the A vector divided by the A absolute. So if in this case a vector projection of this vector on this vector, here is a trick. You have to notice this trick. RAB plus RBC, so it means R vector is started from A, then crossing through the B and ending at C. Here I will try. I will draw it out for the new people. A, this is the vector from A to B, and another vector from B to C, another from B to C. So we can write that it is actually from A to C. So this was the trick for these two vectors. So we can convert these two vectors in a single vector by writing R A C. Okay, so RAB plus RBC on RAD. RAB plus RBC means RAC, starting from A ending at C. So RAC. So RAC means C minus A. This is C and this is initial point A. So C minus A, this is the R A C. Okay, and then RAD, this is RAD minus A. So this is RAD. So the projection according to this formula, uh, projection of RAC on RAD. So RAC dot RAD divided by RAD, because the projection is falling on RAD, divided by RAD into RAD divided by RAD absolute. This is the RAC and then RAD, absolute of RAD, again RAD vector and RAD absolute again. So we will get this vector. The projection of RAB plus RBC on RDC. Similar example, RAB plus RBC means RAC. RAC on RDC. Only the difference is over here. In A it was RAD means D minus A, and now RDC means C minus, initial point is D and final point is C. So first we have to find RDC means RC minus RD. and now the procedure is same as this one. Okay, now the angle between these two. So we have to find the dot product of these two first of all. I've already discussed this in the previous slide. Find the dot product of these two and divided by the absolute of these two and taking the cos inverse of this theta. So we will get 26 degree. You have to consistently use the calculator. So practice of using the calculator is very necessary and mandatory in order to solve these examples. Okay, now uh, differential quantities for the Cartesian and spherical and cylindrical. So differential means the very small length, means if this is the whole length. So the differential means very small portion, means this one portion, this one portion, this portion, this portion. So we can write this as dy, this is also dy, this is also dy. So after taking the integration for the dy's, dy1 plus dy2 plus dy3, so we will get the whole y. Similar is the case with the z, and this is whole z, so the small portion of z will be dz. This is also dz, this is also dz, this is also dz. After taking the integration of these dz's, we will get the whole z. So the differential length or the differential distance will be equal to dx. Dx is the length, differential length in the direction of x, means this one. This is dx in the direction of um, dx in the direction of x, and this is the small portion dy in the direction of y, and dz in the direction of z. So this will be equal to a dl, length having 3 points. Okay, now the differential surface. Note that the surface, uh, having the unit of meter square or centimeter square, so it means two lengths will be involved in surface. So dy multiply by dz means length into breadth. Length into breadth is surface. So if taking the example of dx, this is dx surface. Okay, so this the direction of the surface will be always perpendicular to the surface. So this is dx, sorry, this is dz, z, because this is in upward direction. Now this is this is dx surface, dsx surface, because this surface is perpendicular to x, perpendicular to x. So dsx is in the direction of x, but it is made of the length for this surface will be dy and dz, dz and dy. This is dy, this is dy, and this is dz. Similarly for the dsy, the length and the breadth will be, this is dz and this is dx, dx. So the dx multiplied by the dz means two lengths. will get the surface on the y direction. Similarly, dx into dy. This is the magnitude of the surface, and it will be directed towards the z. So ds surface along x-axis surface along x-axis will be dy into dz. Surface along y-axis, the magnitude for this will be dx, small length of x and small length of z. Similarly, dsz, dx into dy in the direction of z. Okay. Now the differential volume, volume is length into breadth into height. Three distances are now involved. So um, this is the only case. There is only one case, means we have to multiply these three these three small distances to get the volume dx, dy, and dz. Okay. Now, moving to the next slide. Okay, now the differential distance and differential surfaces and differential volume for the cylindrical coordinate system. So d phi, this is rho, phi, and z. These three are the axes for cylindrical coordinate system. Rho, phi, and z. So the small length in the direction of rho will be d rho. A rho is the direction, and d rho is the small length in the direction of a rho. Okay. Now the small length in the direction of phi, phi is not a distance, it is angle. So according to the chord length, this is rho, and if we take this as phi, so this chord length will be how much? S is equal to S is equal to r theta. So here r is rho and theta is phi. So this the length for in the direction of rho will be r d phi. Here r is rho. Okay, so rho d phi, this is this can be get from this formula, S is equal to r theta in the direction of a phi, and z is the length. So no need to apply any other formula. So dz in the direction of az. Okay. So differential surfaces along a rho will be uh, this rho d phi, means the surface of the length of this side, and the length of this side will be dz. Okay. Now the surface along the a phi will be d rho and dz. Multiplying d rho and dz, we will get ds phi, and dsz, this is the length of the phi side, and the length for rho side will be d rho. So multiplying these two, we will get dsz. And for the differential volume, the d rho is the length of for in the direction of rho, and rho d phi, this is S is equal to r theta and dz. So multiplying these, we will get dv for the cylindrical coordinate system. Now the okay, this is the demonstration of this chord line. This is a rho, this is d phi. So this length will be equal to S is equal to r theta, S is equal to rho and d phi. Okay. Now the surfaces for the spherical coordinate system. You know, okay. R, theta, and phi. These three are the theta and phi. These three are the axes for the spherical coordinate system. So the differential length along r will be equal to dr. Differential length along theta will be equal to r d theta. Similar formula, S is equal to r theta. Okay. And we have already discussed in the class that we have to use the perpendicular component of the theta to get the spherical. Means this is r. So phi, taking rotate this r along the theta for 180 degree. No, sorry, to 5 to 5 only, means 180 degree. And now rotate this d perpendicularly for 0 to 25, means 360 degree. Now this will be the phi, but which component? The theta component. This the perpendicular of the theta component is rotating. This is so r according to this, S is equal to r theta. So r r is capital R, and theta will be sine theta d phi. Okay, the perpendicular component of the sine theta will be used uh, to get the whole sphere. Okay, now the differential length will be d r or dlr along r, d okay, dr along r, dr d theta according to this formula uh, r, okay, r sine theta d phi, r d theta, and no, there is a mistake. No, no need of this. Okay, this was the first portion of the lecture, and we will discuss the spherical coordinate system in the second part of the lecture. So thank you for the moment.